This video will introduce you to the concept of distance. You will need for this video a graphing calculator, so if you don't have yours handy, go ahead and pause the video right now so that you can grab yours out of your book bag or from under where your bed or from wherever your calculator has been hiding away all summer. Great. So now that you have your calculator and are good to go, the other big thing that you need to remember while you watch this video is that if you're watching it on a cell phone, you want to make sure you turn the notifications off so that you're not going to run into anything that's going to distract you or disturb you or interfere with your ability to give the video your utmost attention. If you're watching on a computer, again, you want to make sure you're watching at a time where you're able to pay attention and really grasp and hold on to those ideas that are being presented. In the first example, it asks us to find the distance between the points whose coordinates are -2, 1, and 4, 3. And just so that we can get an idea or a picture of what it is that we're being asked to do, I'm going to go ahead and plot using red ink that point whose coordinates are -2, 1, and plot using some blue ink the point whose coordinates are 4, 3. So this question is really saying find the distance between the red point and the blue point. Or in other words, find the length of the line segment that connects the red point to the blue point. So the first big key idea that you need to be aware of with respect to distance is that sometimes the question will ask you to find the distance, whereas other times it may say find the length of the line segment that joins those 2 points. But length and distance, for our intents and purposes, can be used interchangeably. Looking at the graph, it's really difficult for me to find the length of that line segment because that line segment is at a slant. However, one possibility that exists for me is I could build in that right triangle whose vertical leg has a length of 2 and whose horizontal leg has a length of 6. And then I could use the Pythagorean theorem, a little a squared plus b squared equals c squared, in order to find the value of x, where x is the length of that hypotenuse, or the length of that line segment I'm looking for. But I'm going to play devil's advocate here and say, what if I wanted to find the length of that line segment, but I didn't want to take the time to scrounge around and find a sheet of graph paper and plot the points and draw the triangle? Is there a shorter, faster, easier way to find the length of that line segment? And the answer to that is yes, I can find the length of that line segment by using something called the distance formula. Now just be forewarned that when I put the distance formula down on paper and you see it for the very first time, it's going to look very complex and very complicated. And just like with anything else in math, once we sit down and look at it and practice it a few times, we find that it's not really as complicated as it appears upon first glance. So here's what the distance formula says. The distance formula, or the distance d between any 2 points, is equal to the square root of the difference between the x values squared, so x2 minus x1 squared, plus the difference between the y values squared, so plus y2 minus y1 squared. And again, looks fancy, looks complicated. Once you've done it a few times and used it a few times, you're going to become a natural at it. I'm going to go ahead and I'm going to use for my x1 and y1 this first point, but if I wanted to, I could use 4, 3 for my x1, y1. Doesn't make a difference as long as 4, 3 stays together and -2, 1 stays together. So again, I'm going to make this one x1 and that one y1, this one x2, that one y2. And I'm going to go ahead and I'm going to substitute or plug into this formula. So x2 is 4, subtract -2, and that quantity is being squared, plus 3 subtract 1, where the quantity is being squared. And here's where you may be very tempted to say, well, 4 subtract -2 is 6, and 3 subtract 1 is 2, and then I've got to square them, and then I've got to add them. And I'm going to say, don't work that hard. You've got this fancy graphing calculator. Let's use it. Let's take advantage of it. Let's get everything that we possibly can out of it. So I'm going to go ahead and open up my graphing calculator, and I'm going to type in everything that I see there in purple. So I am not going to type in that square root, which has been written in black ink, but rather I'm going to start by typing in with that open parentheses, which is the very first thing I see in purple. You should practice typing this into your graphing calculator as well, so that A, you know what you're doing, and B, if it's going to give you any trouble, you'll find out about it now, and I can help you and answer any questions about it when you come back to class. All right, so I'm going to go ahead and open up my graphing calculator. I want to go to a new document. I don't want to save what's in there. And I want to add a calculator. So I'm going to start with the open parentheses, and I'm going to begin, and I'm going to type in 4, subtract -2, close up the parentheses, square it. To that, I want to add, in parentheses, 3 subtract 1, and then square that. Since I didn't type the square root into my calculator, the square root in the problem still exists. But what I've got underneath the square root is now this 40. So living under that square root, I have a 40. And now you probably already know that if you try to take the square root of 40, 40 is not a perfect square. You cannot take its square root. If you don't believe me, try to plug it into the calculator. However, 40 is not a radical in simplest form because 40 contains a factor that is a perfect square. So I'm going to rewrite radical 40 as radical 4 times radical 10. 4 times 10, 40. You might say, well, why did you choose 4 and 10 and not 8 and 5 or 20 and 2? But 4 just happens to be the largest perfect square that is a factor of 40. So the square root of 4 now I can simplify down to 2. 10 is not a perfect square. I don't have any factors of 10 that are perfect squares, nor can I take its square root. So I'm going to leave that as square root of 10. You are always going to leave distances in simplest radical form unless the directions specify to do otherwise. So the distance between those 2 points, or the length of the line segment with those endpoints, is in simplest radical form 2 square roots of 10. At this point, if I said anything that didn't make sense or that you didn't understand or you feel as though you missed, what you should do is either hit pause or hit stop, hit rewind, and work through that problem again together with me until you feel more comfortable and more confident, more secure, like you've really got it and you really understand it. All right, for those people who do feel like they understand it, I'm going to go ahead and go on to the next example. In the next example, they're telling us that a rhombus is a parallelogram where all 4 sides are congruent. Congruent meaning the same length or the same distance. They're giving us some coordinates of some points, and they're now then asking us to show that that object is a rhombus. So like with the first example, I'm going to go ahead and I'm going to begin by plotting those points just so that I kind of have a good visual of what it is that I'm looking at. So in other words, to show this as a rhombus, I would need to show that all 4 of those sides have the same length or the same distance. So in other words, I would have to do the distance formula 4 times. Once to find the distance between points P and Q, a second time to find the distance between points Q and R, a third time to find the distance between points R and S, and then lastly a fourth time to find the distance between points P and S. In the interest of time and trying to be respectful of your time, I'm only going to find the lengths of 2 of those sides. I am going to once again use the distance formula. And any formula that we use in here in this course this year, we're always going to begin by putting the formula down on the page. So distance is equal to the square root of the difference between the x values, x2 minus x1 squared, plus the difference between the y values, y2 minus y1 squared. And I might begin by going ahead and finding the distance between point P with coordinates -2, 3, and point Q with coordinates 4, 1. But it really doesn't matter. I could start with any 2 of those points. So this time, instead of putting a D for distance, I'm going to put a PQ so that the person reading my paper will know that in this case, because there's more than 2 points in this problem, that I'm starting out by finding the distance between points P and Q. And I'm going to say -2 subtract 4 quantity squared plus 3 subtract 1 quantity squared. Now it's important to notice here that I use this as my x2 and 4 is my x1. If -2 is my x2, then 3 must be my y2. And since 4 was my x1, 1 must be my y1. So this was my x2, my y2, my x1, and my y1. It really doesn't make a difference what you use for x2 and what you use for x1, as long as you pair up the y values with the appropriate x values. The distance from P to Q is really the same as the distance from Q to P. Once again, when I go to substitute or plug this into my calculator, I'm going to begin with the open parentheses. So starting with that open parentheses, I'm going to go ahead and put in -2 subtract 3 quantity squared, and then to that I want to do 3 subtract 8 quantity squared. And again, I haven't taken any square roots, so at this point this lives all under the radical sign. So square root of 50, and like 40 in the first example, 50 is not a perfect square, but it has a factor that is 25 will go in there 2 times. So I'm going to rewrite root 50 as root 25 times root 2, but root 25 is 5 square roots of 2. If you have forgotten how to simplify radicals from your algebra class, you should make it a point to get into the math office sooner rather than later. I would say today is a good time to get some help with simplifying radicals because we're going to be doing that quite a lot in geometry this year. So I found that the length of PQ is 5 root 2. And again, in the interest of time, I may go ahead, I think I'm going to go ahead and stop there just because I've been somewhat long-winded up to this point. But in order to finish this problem, I would go find the length of all 4 of those sides and then show that all 4 of them are the same length, or in other words, have the same distance between endpoints. All right, so I've covered or introduced you to quite a lot in this video. It's been quite a good 13 minutes or so. What I would like for you to do is take some time and reflect and think about what are the key ideas and important takeaways that you're going to have to remember from what I've talked about in these 13 minutes in order to be successful. And then see if you can apply what you've learned to solve the problems on the next page. If you're having trouble solving these problems, a good idea would be to either A, write down where you're having trouble so that I can help you and address your concerns when you come back to class, or B, hit rewind and go back and rewatch those 2 examples that I did and see if you can pick up something that you missed the first time that's important for your ability to be able to solve those questions. All right, as always, thank you for the gift of your time, and I'll be looking forward to seeing you the next time you come back to class.